Chapter 4 Network Layer. Chapter 4 Outline. 4.1 Introduction. 4.2 Network Layer Protocols. 4.3 Unicast Routing. 4.4 Multicast Routing. 4.5 Next Generation IP. Chapter 4 Objective. We first discuss service that can be provided at the network layer, packaging, routing, and forwarding. We then discuss the network layer at the TCP/IP suite IPv6 v4 and ICMPv4. We also discuss IPv4 addressing and related issue. We then concentrate on the Unicast routing and Unicast routing protocols. We then move to multicasting and multicast routing protocols. We finally discuss the new generation of network layer protocols, IPv6 and ICMPv6. 1.1 4.1 Introduction. Figure 4.1 shows the communication between Alice and Bob at the network layer. This is the same scenario we used in chapter 2 and 3 to show the communication at the application and the transport layer, respectively. Figure 4.1 Communication at the network layer. 4.1.1 Network Layer Service. Before discussing the network layer in the Internet today, let's briefly discuss the network layer service that in general are expected from a network layer protocol. Packaging, routing, forwarding. 4.1.1 Continue. Error control, flow control, congestion control, quality of service, security. Figure 4.2 Forwarding process. 4.1.4 Packet switching. From the discussion of routing and forwarding in the forward section, we infer that a kind of switching occurs at the network layer. A router, in effect, is a switch that creates a connection between an input port and an output port, just as an electrical switch connects the input to the output to let electricity flow. 4.1.2 Continue. Diagram. Approach. Virtual circuit approach. Figure 4.3 A connectionless packet switched network. Figure 4.4 Forwarding process in a router when used in a connectionless network. Figure 4.3.5 A virtual circuit packet switch network. Figure 4.6 Forwarding process in a router when used in a virtual circuit network. Figure 4.7 Setting request packet in a virtual circuit network. Figure 4.8 Setting acknowledgement in a virtual circuit network. Figure 4.9 Flow of one packet in a separate virtual circuit. 4.1.3 Network Layer Performance. The upper layer protocols that use the service of the network layer expect to receive an ideal service, but the network layer is not perfect. The performance of a network can be measured in terms of delay, throughput, and packet loss. We first define these three terms in a packet switch network before we discuss the effect on the performance. 4.1.3 Continue. Delay. Output packet loss. Figure 4.10. To put in a path with 3 links in a series. Figure 4.11. A path to the Internet backbone. Figure 4.12. Effect output in a SHA link. 4.1.4 Network layer congestion. In chapter T, we discussed congestion at the transport layer, although congestion at the network layer is not explicitly addressed in the Internet model. The study of congestion at this layer may help us to better understand the cause of congestion at the transport layer and find possible remedy to be used at the network layer. Congestion at the network layer is related to two issues, throughput and delay, which we discussed in the power section. 4.1.4 Continue. Congestion control. Open loop congestion control. Closed loop congestion control. Figure 4.13 Packet delay and throughput and as function of load. Figure 4.14 Partial method of everything congestion. Figure 4.13 show packet. 4.1.5 Structure of a router. In our discussion of forwarding and routing, we represent a router as backbox that accepts incoming packet from one of the input port. Use a forwarding table to find the output port from which the packet departs and set the packet from this output port. In this section, we open the backbox and look inside. However, our articles won't be very detailed. In the book I have been writing about router, we just give an overview to the reader. 4.1.5 Continue. Component. Figure 4.16 Router component. Figure 4.17 Input port. Figure 4.18 Output port. Figure 4.19 Crossbar switch. Figure 4.11 Barnyard switch. Figure 4. Example of flooding in a barnyard switch. Figure 4.22 Partial barnyard switch. Chapter summary. The Internet is made of many networks connecting those connecting devices, as of which act as a router or as a switch. Two types of switching are traditionally used in networking: circuit switching and packet switching. The network layer is designed as a packet switch network. The network layer supervises the handling of packets by the underlying physical network. Delivery of packets can be direct or indirect. Two categories of forwarding are defined: forwarding based on the destination address of the IP datacam, and forwarding based on the label attached to an IP datacam. Thank you.